Hello everybody, I am incredibly excited today to give you the first demonstration of quite a sophisticated AI running on blockchain. That blockchain, of course, is the internet computer, the only blockchain in the world today that can run compute at scale. There's a lot of talk about, blockchains for AI, tokens for AI, and things like that. This is the real deal. This is AI running on a blockchain. So today I'm going to demonstrate image classification, which involves a neural network running inside a smart contract. In fact, that neural network has been compiled to WebAssembly, which is what runs on the internet computer. Okay, so without further ado, let's get started. So this web page you see here is being created by Canister smart contract with the AI inside.
For years, the crypto world has pushed the limits of what digital technology can do. But as the industry grew, so did one uncomfortable truth. Many blockchains were consuming far more energy than anyone expected. The criticism wasn't just noise. Entire mining farms appeared around the world. Electricity demand skyrocketed, and suddenly the conversation around innovation was overshadowed by concerns about environmental damage. But not every blockchain followed the same path. While most networks focused on speed or security, a few started asking a different question. Can decentralization evolve without draining the planet? That question led to one of the most interesting breakthroughs in Web3 today. The Internet Computer Protocol, or ICP, didn't try to minimize its footprint at the edges. It redesigned the foundation. Instead of borrowing methods from older systems, it built an architecture that runs efficiently, scales naturally, and maintains a carbon-neutral profile from the ground up. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. The conversation about blockchain and the environment has been going on for years, but it has reached a point where it shapes public opinion more than anything else. Early in crypto's journey, people looked at the technology with excitement. The idea of open networks, digital ownership, and decentralized computation caught the world off guard. But at the same time, a shadow formed around the industry. Reports started showing how much electricity some networks were consuming. Diagrams compared Bitcoin's energy use to entire countries. Critics began calling blockchain a threat to climate goals. The issue grew so large that even supporters of decentralized technology started to question where things were heading. Closer look at a blockchain that answered those concerns in a serious and structural way. The Internet Computer Protocol, or ICP, didn't try to patch a broken system. It reinvented how a blockchain should function. By focusing on efficiency, advanced cryptography, and on-chain smart contract hosting, it created a platform that achieves carbon neutrality without compromising performance. To understand why carbon-neutral blockchain matters, it's helpful to revisit how the problem started. Traditional proof-of-work systems rely on miners solving mathematical puzzles. The more miners join the network, the more competitive the system becomes. This competition pushes energy consumption higher and higher. The growth of crypto mining operations led to entire warehouses filled with machines running nonstop, producing heat, noise, and enormous electricity bills. While this approach provided strong security, it also created a reputation challenge. Environmental groups pointed to rising emissions. Governments started discussing regulation. Even mainstream audiences who loved digital innovation became skeptical once they learned about the energy impact. The narrative around blockchain shifted, and it became clear that a long-term solution required deeper, smarter engineering rather than surface-level fixes. That brings us to carbon neutrality. At its core, carbon neutrality means balancing the emissions produced with initiatives that remove or offset those emissions. But in the context of blockchain, it means something more. It means designing a network that avoids unnecessary energy waste from the start. It means building the protocol in a way that reduces the need for massive physical infrastructure. It means creating a system that consumes less power for the same amount of work. Many crypto projects have made promises about sustainability, but the real test is whether the architecture reflects those values. ICP is one of the few networks that built energy efficiency into its foundation instead of treating it as an add-on feature. The foundation of ICP's sustainability starts with its key innovation, chain key cryptography. This mechanism replaces the heavy, resource-intensive consensus systems used by older blockchains. Traditional networks often require thousands of machines running complex computations in parallel just to validate and finalize transactions. ICP takes a different path. Chain key cryptography allows the network to generate a single public key for the entire chain, enabling fast validation and lightweight computation. The architecture keeps energy use low even when the network scales. It also allows ICP to support features that most blockchains can't offer at this scale, such as hosting full applications directly on-chain. Another major difference comes from how ICP handles smart contracts. Instead of standard smart contracts that operate with limited storage and slow execution, ICP uses canister smart contracts. These canisters are high-performance computational units that act like self-contained software systems. They can store data, run logic, serve web content, and process user interactions. Because ICP controls the entire execution environment, the system can optimize resource usage at a level that traditional networks never achieved. Canisters consume predictable energy, avoid unnecessary computation, and reduce the need for external servers. By keeping everything on-chain, ICP removes the energy overhead caused by third-party infrastructure such as centralized cloud storage. When a blockchain relies heavily on off-chain servers, emissions increase even if the blockchain itself is efficient. Every database request, web page hosting, file storage, and load balancing system requires additional energy. ICP eliminates that dependency. Hosting directly on-chain creates a closed loop of efficiency. Developers don't need Amazon Web Services or independent server farms. The network becomes the application host, the database, and the computation layer. This alone gives ICP a significant environmental advantage, because most Web3 applications today still depend heavily on cloud providers with large energy footprints. Although architecture plays the biggest role in lowering emissions, ICP also reinforces its commitment through verifiable carbon offset initiatives. The network partners with environmental organizations that work on reducing atmospheric carbon through reforestation, renewable energy support, and carbon capture programs. These partnerships aren't speculative or loosely defined. They are measurable and trackable. By combining reduced energy use with verified offsets, ICP maintains a consistent carbon-neutral profile. This approach shows responsibility not just at the engineering level, but at the operational level as well. Another important part of ICP's sustainability model is its governance structure. ICP uses a decentralized governance system called the network nervous system, which allows community members to vote on upgrades and protocol changes. This provides a unique advantage for long-term environmental planning. When a new efficiency improvement or sustainability proposal is ready, the community can vote to integrate it into the protocol. This ensures that environmental responsibility isn't controlled by a single company or limited group. It becomes a continuous, decentralized process where the entire ecosystem can participate. As technology evolves, ICP can evolve with it. Looking ahead, the roadmap for ICP includes even more optimization. The network is exploring ways to reduce computational costs, improve the efficiency of canister upgrades, and decrease memory usage without affecting performance. Engineers are also working on reducing the energy footprint of data centers that host ICP nodes. By integrating renewable energy sources and optimizing hardware requirements, ICP aims to push its carbon neutrality even further. These improvements show that sustainability is not a marketing angle. It's an active part of the project's long-term direction. While protocol-level sustainability is impressive, the question many people ask is whether this translates into real-world use. The answer is yes. Several projects built on ICP demonstrate how its energy-efficient design can support meaningful applications. Decentralized social platforms, content hosting networks, data storage applications, and on-chain services all operate within ICP's efficient framework. Developers who want to reduce their environmental impact can build on ICP knowing that their applications are running on a network built for sustainability. This appeals not only to independent developers, but also to companies seeking a blockchain solution that aligns with corporate sustainability commitments. Traditional blockchain apps often depend on external APIs, cloud hosting, and centralized services. This hybrid approach increases emissions and weakens decentralization. ICP's model lets developers build complete applications entirely on-chain. When everything from the front end to the back end exists within the protocol, the environmental impact drops significantly. This allows businesses to create cleaner digital products that still enjoy the benefits of decentralization and user ownership. It also simplifies compliance requirements for companies operating under sustainability guidelines. Several green-focused projects see ICP as an ideal foundation. Climate monitoring platforms can use on-chain data storage to preserve environmental records transparently. Supply chain systems that track sustainable products can operate with lower energy footprints. Decentralized research platforms can store results directly on-chain without relying on polluting server farms. Environmental organizations exploring Web3 tools can create verifiable registries, transparent reporting systems, and data-driven applications while keeping their ecological impact low. Because ICP removes the need for external hosting layers, these projects can remain fully decentralized and environmentally conscious at the same time. As the blockchain industry grows, sustainability will influence user adoption, developer preferences, and regulatory environments. Networks that continue relying on outdated consensus mechanisms will face pressure to change or become irrelevant. ICP provides an example of how efficient design, advanced cryptography, and strong governance can redefine what a blockchain should look like. Instead of choosing between performance and environmental responsibility, ICP proves that both are achievable when the architecture is built with the future in mind. The broader implications are significant. A carbon-neutral blockchain like ICP shows that decentralized technology can scale without contributing to environmental degradation. It sets a standard that other networks are likely to follow. As governments and organizations push for cleaner digital infrastructure, protocols with sustainable foundations will stand out. ICP demonstrates that forward-thinking design can solve the energy challenges that slowed crypto's image for years. In the future, the Web3 landscape will favor platforms that combine efficiency, security, and sustainability. Users and companies will want systems that align with modern environmental expectations. ICP is well-positioned to serve that role. By hosting websites, applications, digital identities, and data directly on-chain, the network eliminates large categories of infrastructure that contribute to energy waste. Every improvement in the ICP ecosystem has a direct impact on the global footprint of decentralized technology. To close, ICP's carbon-neutral blockchain innovations offer a clear view of what the next generation of decentralized systems can achieve. It shows that energy efficiency doesn't require sacrificing performance. It proves that cryptography and smart engineering can solve problems that once seemed unavoidable. Whether you're interested in climate responsibility, decentralized computing, or the next evolution of Web3, ICP represents a meaningful step forward. The industry needs cleaner solutions, smarter architecture, and responsible growth. ICP provides all three. The future of blockchain doesn't have to follow the mistakes of the past. A cleaner, sustainable, and scalable model is already here. All right. If you learned something new or enjoyed this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.